What is Luxor? A city in Egypt? A casino in Las Vegas? Or one of the coolest software packages available in any programming language? If you guessed all three, then you're technically correct. But since this is a channel dedicated to the Julia programming language, I'm going with door number 3. Today, you're in for a special treat, since we're going to get an introduction to the Luxor.jl package. What is Luxor.jl? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
In today's tutorial, we'll get an introduction to the Luxor.jl package. According to the Luxor.jl documentation, Luxor is a Julia package for drawing simple static vector graphics. This is perhaps the biggest understatement ever. While on the surface, Luxor may simply be a computer graphics illustration package, it is capable of so much more. Getting an introduction to Luxor is kind of like going to an all-you-can-eat buffet for the first time. You'll be tempted to try everything at once, but if you do that, you'll end up with a tummy ache. So it's best to take things slowly and try out a few things first, and then come back to try some other items later. This is the approach that I'll be taking when introducing the Luxor package. Luxor is capable of so many amazing things, but you really need to start at the very beginning by learning the fundamentals of drawing with computer graphics before you can move on to the more advanced material. We'll start by learning how to draw simple lines and shapes, including text, and then we'll learn how to export our drawings using various file formats. We'll also get an introduction to generating drawings programmatically using Julia code. For this tutorial, knowledge of Julia and VS Code is required. Okay, let's get started. The Luxor.jl package was created by Cormolian, who has one of the coolest channels on YouTube. If you're not subscribed to Cormolian's channel yet, then you should pause this video and subscribe to Cormolian's channel first, and then come back here to watch the rest of this video. On that channel, there are some incredible demonstrations of what's possible using Luxor. Luxor.jl is based on Cairo, which is an open-source graphics library written in C that's been around since the year 2003. But Luxor.jl is not simply a Julia wrapper for the Cairo library. There actually is a Julia wrapper for Cairo called Cairo.jl. Going back to the Luxor documentation, the focus of Luxor is on simplicity and ease of use. It should be easier to use than plain Cairo.jl with shorter names, fewer underscores, default context, and simplified functions. I would normally start my tutorials with some background information and concepts, but with Luxor, I think it's probably best to jump right into VS Code and to start drawing. In the VS Code Explorer panel, create a new folder for this tutorial. In the tutorial folder, create a new file called Luxor_cheatsheet.jl. Launch the Julia REPL by using Alt-J, then Alt-O. Maximize the terminal panel. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Add the Luxor package. Type in status to confirm the version number. Exit the package REPL by hitting backspace. Minimize the terminal panel. Okay, let's start using Luxor. The easiest way to create a drawing in Luxor is by using the @draw macro. In VS Code, the Julia Plots panel should appear showing a black horizontal line on a white background. Now, let's talk about a few things. By default, the @draw macro creates a 600 by 600 window with a white background having an origin located at the center of the window. The window does not use the Cartesian coordinate system. The horizontal axis is the same as the x-axis on the Cartesian coordinate system, so positive numbers are to the right of the origin and negative numbers are to the left of the origin. But the vertical axis is flipped, so that positive numbers are below the origin and negative numbers are above the origin. For those of you with a math or science background, this may appear unusual. But this is the standard coordinate layout for most computer graphics applications. So, along the horizontal axis, -300 is the left edge of this window, and +300 is the right edge of this window. And along the vertical axis, -300 is the top edge of this window, and +300 is the bottom edge of this window. So going back to our code, you can draw a line by using the line function. 2 points define a line. On this line, point -250, 0 is the left point, and +250, 0 is the right point. The stroke symbol indicates the action that you want Luxor to take with regard to those 2 points. By default, the stroke color is black. We'll discuss colors in a few minutes. Okay, let's try to draw a vertical line. So just to review the coordinate system, point 0, -250 is the top point, and point 0, +250 is the bottom point. Okay, now let's try to draw a diagonal line. So here, point -250, -250 is the upper left point, and point +250, +250 is the bottom right point. Got it? It may take some getting used to if you've never used a computer graphics package before, but with some practice, you'll get the hang of it. In addition to drawing lines, you can also draw arrows by using the arrow function. When drawing arrows, you do not need to include the stroke action. By default, the arrowhead will be placed at the second point. Okay, so you get the idea. In order to draw lines and arrows, all you need are 2 points, and Luxor will do the rest. Now, how do we draw a circle? In order to draw a circle, you can use the circle function. When using the circle function, you need to indicate the location of the center of the circle and then specify the radius. In this example, our circle is centered at the origin and has a radius of 200 units. By the way, these units are not pixels. They are points, like the points used for font sizes. With vector graphics, all dimensions are relative, so these units do not represent absolute measurements. Okay, now how do we draw a box? There are a couple of ways to draw rectangular shapes in Luxor, but a simple way is to use the box function, where you need to specify the location of the center of the box, and then provide the width, and then the height. Until now, we only had to use a single function to generate our drawings, but in order to create more sophisticated drawings, you may need to use several functions. In order to use multiple functions with the @draw macro, you can use a code block by using the begin and end keywords from Julia Base. The set- function allows you to select a different stroke pattern for your drawings. Here, we're using it to create a circle with a dotted line. There are a lot of different options that you can use with the set- function, so I will simply refer you to the Luxor documentation if you're interested in seeing more options. Now, let's try combining everything that we've learned so far. As you can see, by including multiple functions, you can create some interesting drawings. We will be using this drawing as a guideline template for the rest of this tutorial. The arrows here indicate the positive directions for the coordinate system, just as a reminder where the positive and negative numbers are located. We can take it a step further by turning this code block into a function, so that we won't have to keep retyping it every time we want to use it. That last call for set-solid will set the stroke style back to the default setting of solid. Okay, now let's learn how to draw some shapes. The easiest way to draw shapes in Luxor is by using the n-gon function, as in a polygon with n number of sides. In order to draw an equilateral triangle, you can use the n-gon function to draw a polygon with 3 sides. The way this n-gon function works is that it inscribes your polygon inside a circle with a given radius. So here, Luxor is using an invisible circle with a radius of 200 units as its guide, and then inscribing a polygon with 3 sides inside it. That 200 is not the length of the side of the triangle. It's the radius of the circle that it's sitting in. I'm going to skip that fourth argument for a second to point out that you need to add the stroke action as a keyword argument here. Okay, going back to that fourth argument. That fourth argument of 0 is for the orientation of the polygon. The Luxor documentation contains a diagram showing the initial orientation for various polygons. By default, point 0, or the starting and ending point for the polygon, is where the circle intersects the horizontal axis on the right. Luxor will then generate the other points by moving clockwise along the circle so that point 1 is the lower left point, and point 2 is the upper left point, and then point 3 is the same as point 0 to close out the polygon. Regarding the orientation, our triangle looks like it's pointing to the right. If you want to change your drawing so that the triangle is pointing up with a horizontal base, then you can change the orientation number. That orientation number is in radians, not degrees. So if you want to rotate your drawing clockwise by 180 degrees, then use pi. If you want to rotate it clockwise by 90 degrees, then use pi divided by 2. In our case, we wanted to rotate our triangle counterclockwise by 90 degrees, so we used negative pi divided by 2. By the way, you don't need to use these guidelines. When I was trying to learn how to use Luxor, I had a difficult time visualizing what Luxor was doing. As you can see, without the guidelines, this is just a triangle floating in space, without any reference points. When I drew this triangle for the first time, it wasn't clear to me why it was positioned where it was, or how the dimensions were being calculated. Without knowing any better, to me, it looked like the triangle wasn't centered in the window. But once I added the guidelines, I realized what was going on. As you can see, the invisible circle is centered in the window, and then the triangle is simply inscribed inside that circle, which makes a lot more sense. Okay, let's move on to drawing a square. Copy and paste the code for the default triangle. As you can see, all we had to do was change the 3 to a 4. Like the triangle, the starting and ending point for the square is the point where the circle intersects the horizontal axis on the right side. And then Luxor travels clockwise along the circle to add points at the bottom, the left, and the top before closing the loop on the right. You can rotate this drawing just like you did with the triangle, but this time we don't want to rotate it by 90 degrees, since that will result in the same image. Here, we need to rotate this image by 45 degrees, either clockwise or counterclockwise. So that means using pi divided by 4 or negative pi divided by 4. Earlier, we created a box using the box function, where we could enter the width and the height. Since this square is a polygon, all of the sides have equal length, and the only way to resize it is by changing the radius of the circle that it's inscribed in. Okay, let's take a look at one last polygon. So, you get the idea. All you need to do is change the number of sides, and then Luxor does the rest. Just like the triangle, you can rotate this drawing 90 degrees counterclockwise, or negative pi divided by 2, to make it upright. For these polygons, you can make the number of sides as high as you like, but after some point, it will just look like a circle. So that does it for polygons. Let's take a look at how to draw ellipses and arcs. In order to draw an ellipse, just use the ellipse function. For the ellipse function, the first argument is the location of the center. The second and third arguments are the width and the height dimensions respectively. You can swap the width and height to change the orientation. Earlier, we learned how to draw a complete circle, but it's often helpful to be able to draw segments of a circle, or an arc. In order to draw an arc, use the arc_to_r function. For the arc_to_r function, the first argument is the location of the center of the invisible circle that the arc is based on. The second argument is the starting point along that invisible circle, and the third argument is the ending point that is clockwise along the invisible circle. You can use this arc_to_r function to draw any segment of a circle, not just semicircles. So in this example, the arc starts at the same point at the top, but terminates at the point on the right. So that does it for basic shapes. Believe it or not, you can draw most things with just lines, circles, and basic shapes. I would encourage you to go through these examples on your own and change the dimensions to get a better feel for how Luxor works. Now that we know the basics, let's learn how to add some text to our drawings. If you just want to add some simple text using the default settings, you can use the text function and include your string as the argument. On my screen, the default setting appears very small, so more than likely you will want to use some custom settings for your text. For the set fonts function, you should be able to use any font and font size that are available on your operating system. For the set text function, you can use left, center, or right for the horizontal alignment, and you can use top, center, or bottom for the vertical alignment. So that's pretty easy. Now that we know the basics of how to draw and how to add text, let's add some personality to our drawings by learning about colors, line width, and fill. The Luxor documentation has a section called Colors and Styles that contains a table showing all of the named colors that are available for you to use. As you might expect, this table was created using Luxor, and it's a very handy reference because it's very compact and it shows all of the colors on one screen. Let's start with something simple, like changing our circle from black to red. By default, the add_draw macro uses the color black for the stroke color. All you need to do to change it is to use the setColor function and enter in your named color as a string. Our red circle looks a little thin. How do we make the line width thicker? In order to change the line width, just add the setLine function. The default setting is 2, so any number greater than 2 will make the line thicker. Now, how do we fill our circle with color? In order to fill a shape, just change the action from stroke to fill. Okay, let's try to apply everything we've learned so far by creating a simple logo. All of my source code is available in my GitHub repository, so don't worry if you don't catch all of this code while watching the video. Pretty cool, huh? Comment out the guidelines to take a look at a clean version of your award-winning logo. Now that you know how to create drawings, you'll want to export your drawings so that you can use them in your projects. Fortunately, Luxor makes it very easy for you to export your drawings as an SVG file, a PNG file, a PDF file, or an EPS file. All you need to do is use the same code that you used for your drawings, but change the @draw macro to either @SVG, @PNG, @PDF, or @EPS, and then add the dimensions and file name after end. don't forget to change the file extensions when saving in different file formats. In your Explorer panel, you should see a file called mytriangle.svg, which you can view either in a web browser or by using some other image viewing application. By default, Luxor uses a white background. You can change the background color, but I haven't been able to figure out how to save a transparent background using Luxor. But it actually doesn't matter because I'm going to show you a life hack that will change your life. No, I'm kidding. It won't change your life. But it will make it easy for you to give your SVG image a transparent background. In VS Code, if you double-click on your SVG file, you'll see that the SVG file is just a text-based XML file. You can go into your SVG file and modify it just like you could with any other piece of code. Line 4, that starts with a rectangle element, contains the instructions for the background. If you scroll to the right, you'll see a style attribute. If you change the values and save your file, it will alter your image. Go ahead and change the RGB settings to 100%, 0%, and 0%, and then save your file. Your image should now have a red background. If you scroll a little further to the right, you'll see the settings for the fill opacity. This is the alpha channel. You can use any number between 0 and 1 inclusive, and it will alter the transparency of your background. A value of 1 means that your background is completely solid. A value of 0 means that your background is completely transparent. Go ahead and change the value to 0 and save your file. Your image background should have disappeared, so now you have a transparent image. Pretty cool, right? Anyway, let's get back to the tutorial. The rest of these exports are exactly the same, so I'm going to go through these quickly and then show you the results. The EPS file format is not very common, so you may not have an application that can open it. I'm viewing this EPS file using Adobe Illustrator just to demonstrate that it works, but this app is certainly not required for this tutorial. If you have a graphic design background, you probably have an app that can open this file format. And that's it. As you saw, it's relatively easy to draw images and to export images using Luxor. But a lot of what we did can be done using a simple drawing app. So you may be wondering, why do you need Luxor? Well, the real power of Luxor is being able to generate drawings programmatically by using Julia code. Let's take a look at an example to see what I mean. Let's try to create an asteroid shape just by using straight lines to give the illusion of smooth curves. You may have done this in school using graph paper and a straight edge. We can do this quite easily using Luxor and a simple for loop. So, some comments here about the code. We changed the background color from white to antique white by using the background function. The guidelines are the same ones that we've been using throughout this tutorial. I made the lines thinner by using a set line value of 0.5. The first two lines are just the horizontal and vertical lines. The line functions in the for loop are for the lines in the lower right quadrant, the lower left quadrant, the upper left quadrant, and the upper right quadrant. Each pass of the for loop simply shifts the points for the new lines, which results in this nice pattern. It is possible to do this using a simple drawing app, but it might take you a while. Here, the time required is just the time that you need to type in this code. Let's save our drawing as an SVG file and then zoom in to take a look at the details. As you can see, there is no loss in quality as we zoom in. It's hard to believe that this image is made just using straight lines. It really does look curved, even zoomed in. Today, we got an introduction to the Luxor.jl package. We started by learning how to draw lines, arrows, and circles. Then we moved to polygons and some other simple shapes. We learned how to add text to our drawings and also how to customize our drawings by adding color, changing line weights, and by adding fill. We learned how to export our drawings, and then we got an introduction to programmatic drawing, which opens the door to many creative possibilities. If you're new to the world of computer graphics, it may seem like we covered a lot today, but in reality, we've barely begun to scratch the surface of what Luxor has to offer. Hopefully, this tutorial has left you hungry for more, so you'll be happy to know that I'm planning another Luxor tutorial for next week, where we can dig a little deeper into Luxor's capabilities. So stay tuned for that. Don't forget to subscribe to Carmullian's YouTube channel, and please go to the GitHub page for Luxor.jl and leave a star. Well, that's all for today. If you made it this far, congratulations! If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julie tutorials, please be sure to subscribe and hit that bell. If you like what I do, then please consider joining and becoming a channel member. New tutorials are posted on Sundays/Mondays. Thanks for watching, and I'll see you in the next video.